Okay, so I think we're ready to go here on the IF stage alignment check. So I'm just going to apply the power to the radio. And the light didn't come on. Okay. Okay, everything's fine. I'm going to give it the full power here. Oh, there comes the radio. So I have it switched to broadcast band. The antenna it's connected to is the loop antenna, which is now hanging up here out of the way from my ceiling. It's in that bag now. The signal generator is connected to this coil. I'm just going to try to transmit into the antenna above. I don't know how well this is going to work. My first attempt here, I don't want to actually hook wires up to the radio. If I can avoid it, probably will have to do that in the end. So we're trying to sneak, and I'm also trying to sneak 455 into the radio through the antenna, which is not really appropriate, but we're going to try that first. So shouldn't matter where I have this tuned. So I'm going to turn the signal up full blast here. Still don't hear anything. And I'm going to tune. It's a little tough, I think, for you to see. Yeah, you can kind of see the number here, 451. Let's move this around. Okay, I didn't hear a thing. So we're going to put this much closer. This is probably not going to work. Oh, okay, here's something now. Hang this right up here. Good. Okay, so a crashing sound will be the sound of that antenna coming down. That's good. Let's give it full power now. What's it at anyway? 100 volts. So we're going to give it 120 volts. Let them have it. So now we'll tune this. I'm trying to keep an eye on this meter here. Where? This one over here. This is tricky for me video-wise. Let's do this. Just watch that meter. It supposedly is registering the AVC. Let's just make sure it is. A 50 volt scale, DC minus, a negative voltage is up scale. Let's tune. Oh, I don't see any movement on that meter at all. Nothing at all. So what's the problem here? Okay, so I may have this connected in a wrong spot or something. Ooh. Should be going upscale. I got a bad clip lead again. Don't think so. I don't think so. Let's try this heavier one here. Okay, a couple places to get ABC. One is here. You can see the meter going up, and the other end of that same wire is here. You know, it was a bad clip lead. I can hear the radio quieted down a bit too. Of course, I'm drawing a little bit of energy out of the detector signal to run the meter over here, which is now upscale a tiny bit. Whoops, let's just double check that. Let me tune around here. Barely moving. So the tone you're hearing is interference from an adjacent noise signal here in my shop, causing that heterodyne tone. The main one you want to hear is the more musical one. That's really coming from the signal generator. Okay, so this guy is tuned to max. Can you read the number up here? 461. So I'm sure it's supposed to be 455, maybe 456. It's a little off. So let's see if we can peak it up now. So I think I'm going to use this guy here. I'm going to start on the second IF. So that'll be this one as opposed to this one. So we're going to come in here, and I got to get the camera showing that voltmeter. So I'm going to pop it up in the screen over here. Let's just hang on and see if I can do this quickly live. I'm not sure I really can. Click all these different options. Over there would be position number 4, and we want to pop up that camera, which is not exactly aimed at the right thing. Are. This is the kind of stuff, if I edit anything out of my videos, it's this kind of stuff that I edit out. Or I'm setting things up. Okay, let's see if I can get rid of that hot flash on the screen there. A little dark under here, but it's okay. Perfect. Now the objective now is to raise the meter reading. Don't be fooled by the sound, he says to himself. You know, when I'm tuning in at 461, I don't want to do that. I want to tune this in at there. Okay, here we go. Okay, we're just doing this kind of roughly. We want to make sure that there isn't a huge loss of signal in these stages. At this point, we're just trying to verify. Now they're all going to show a peak because I'm relocating the tuning point to 455 from 461. So they're all going to go up. Right? It doesn't mean they weren't up before. Now I got to go from the top. Actually, I went and did both the bottoms. That's not quite the way to do it, but that's okay. I'll get the top one here. Top one on the second can. So we're kind of getting back to the same ADC voltage right around 6 there. I'm on the 5-volt scale, so that's actually not much. But you can hear the noise in the background in the signal. That's a regular radio atmospheric noise, if you like, or maybe not atmospheric, but that says the signal, the IF signal I'm ramming into the radio through the antenna is not very strong. That's good. Okay, ready now? Watch the meter. Oh my gosh. Okay, so we found something there. So I don't want to start making capacitor replacements with the IF and the rest of the radio badly aligned. This doesn't have to be perfect. I don't want it badly aligned. This also tells us the capability of the radio as it sits. So I think we went from 6 volts to 9 volts. That's quite a dramatic increase. That's good. Okay, now there's some other tuning issues. There's all these capacitors here. Okay, so what I've done so I can't get things wrong is I've written this on the side here. What we're interested in is just making sure that this adjustment is within the ballpark and not way out. So there's another question of peaking up that meter you're looking at, but I can't do it with the 455 signal. I need to do it with a regular radio signal. So the radio's tuned, I don't know, 1200, something like that, I'm guessing. So we're going to redo the signal generator to 1200 or thereabouts. Okay, let's listen. You can hear a thing. Full power. Oh. Uh-oh. Oh, how'd I get on the B band? Okay, A band. I was on the B band. Don't know why. Let's try it again. 1200. Power down. 1200. Come on. Well, where are you? Hey, look, I'm just past the center on there. Let's take a look. On the radio, that would be about 1200. Why? Give it all the juice. Hey man, 1200. What's up here? Let's just tune the radio around, see what we got here. Sounds great. We go dead center. Dead center frequency is basically 900. Oh. There it is. Barely hear it. Certainly see it on the ABC though. Okay. I want to peak that up or see what happens when we adjust this guy here. Let me change the scale. Okay. Okay, watching the meter. Should be doing this at 1400. So, well, only if you really kill it down there. It's fine. It's not killing the signal. It's not doing anything bad. The other adjustments are for the oscillator. We don't need to fiddle with those right now. What we've done here is we've just got the radio performing as well as it can in terms of sensitivity. So there's a couple of approaches here. I can start with focus on the audio circuits, which over here, or I can start with focus on the radio circuits. Focusing on the radio circuits means the AVC measurement on the meter in front of you there becomes really critical in seeing the improvement in the radio. Focusing on the audio circuits is a question more of volume getting greater, which won't be on this meter over here at all, or tonal quality improving, which is really hard to judge because we need some kind of more musical type signal to do it. So I'm going to think about that a little bit just before I get going on it. Okay, so the next step now is going to be to kind of take over the input of the radio, the antenna input, with the signal generator. Stop using this. Stop using this coil here and make a direct connection. And this will hopefully knock some of the noise out too. I'm expecting that. And now on the antenna, kind of worked backwards to what I was expecting, but that's okay. Now, let me just check the tuning here. Where'd it go? Maybe I tuned the radio or something. By the way, I can see the magic eye is glowing, by the way. Okay, a little bit blurry vision there, but I think the magic eye is working completely. It's just dull. So ABC's giving me a little bit of headache. There we are. That's quite a strong signal being sent into this radio. The reception is kind of crummy. Okay, no question you saw those. So that stands as a warning to me that maybe things aren't quite the way I thought they were. I wouldn't expect any of those sparks to happen. So I'll look into this just a little bit because it's a warning. It's essentially a warning to look at. Now, let's think about this. That's a really mysterious thing I just saw, because you see this ground lead is connected from a meter over here, whoops, which has basically a green wire connection all the way around to this piece of equipment, which is the one that was sparking. How can that be? Sparks. What has happened? Oh, I can see why. Okay, I see why. Uh-oh, this might have been a problem for a while in my shop. This might have been a problem for a while in my shop here. So there's the major equipment grounding lead, this green wire, and it's come off the ground terminal here. Son of a gun. I wonder how long it's been like that. Okay, I'm going to stick that back on. Son of a gun. Wasn't I having fun problems in my shop and everything? Be careful to not get a shock while I'm doing this. Okay. That'll end that little thing. Sound the same, they should be the same. Okay. Get the meter on. Okay, you can see it, oh yeah, on the screen here, if I just fix the camera a bit. Oh my gosh, where are we at now? Feeding this signal in. I think that's a little better. That's a little better. Power down. Nope. Wow, we're still pounding a huge signal in there. Is this tuned in right? No. That's what. Okay, down. Tune in. So the reason the meter goes up and then falls back a little bit is the AVC, the delayed action of the AVC. And that's what makes aligning a radio with the AVC active, too high of a signal coming in, triggering AVC voltage, becomes tricky. It doesn't become impossible, it just becomes tricky. Now, I think we're all set here, except we don't have audio showing up. I'm going to take this light out because I don't think it's helping at the moment. So you're trying to get an eyeball on this meter here. This one should be showing the sound level at the speaker. Let me turn the speaker up. There you are. It almost seems overly sensitive, but that's a decibel meter there, a dB meter, dB audio meter, so it's kind of, that's good. So what this should enable me to do now is alter the radio, change parts, and see the effect on both the AVC and also on the audio output. The AVC shouldn't change while I'm working on audio circuits, but the audio output should. Now, how stable is all this? So for instance, I have to turn the set on and off. Well, I turn it on and off by switches over here, so I can leave all the tone control and the volume just as they are. And the frequency stability while I'm doing this, the audio circuit shouldn't affect any of that, of course, but I'll be turning the set on and off, on and off. If I guess while I'm working on the audio circuits, I don't have to worry about the tuning of the radio too much. If something happens and it's out of tune, I can just tune it back in. It's no big deal. What's really a big deal is seeing the variation on that meter there as I do stuff. I kind of doubt it. I'm not going to see anything. What am I going to do? First thing I think I'd like to do is the blocking capacitors in the audio circuits. Or, yeah, maybe that's a first. Or the first one might be the capacitor that can, let's do this. The capacitor that conveys the audio from the volume control forward into the audio circuits of the radio. That's the first capacitor to do. And which one would that be? Let's find it. Turn down the radio here. I don't think we need to listen to that so loudly. Okay, so what we're looking for is the capacitor that conveys audio from the volume control to, let's start with a schematic. Volume control, here it is. And then there's a capacitor here. Its job is to convey the audio but keep any DC from getting through into here. This is going straight to a grid on the triode of this tube, and it has a big 10 megohm resistor here, so it's a grid leak kind of setup, I believe. It's sort of a self-biasing kind of thing. That's the capacitor, 0.0025. That could be paper or it could be something else. Let's take a look and see if we can find it in a radio now. It's right on the volume control. Hey, that's a good one to pick, Jim. That's an easy one. Okay, right on the volume control. Volume control is here. And I think I pointed this out before. It's this big honking thing here. That's supposed to be a 0.0025. Well, there's no question. That's the capacitor, so that's the one we're going to change. So let's get things set up here. So I want to raise the volume to a point where the meter. Do I dare make this meter more sensitive? No, I don't think I should do it this way. Okay, so we'll set this to, you can't see the dial, but it's -4. It's almost straight up. Tune the radio, make sure it's tuned properly here. Uh-oh. Don't watch the AVC meter. Don't watch the audio meter. I can't imagine it being any better than that. Audio's just up a bit, by 0.4. Okay, everybody set? Power off. This capacitor comes out. Comes out. Now, what's this one worth? What's he worth? 002. Looks like 25. 0025. Okay, let me find a .0025. Now, when I got a .002, I got a .003. 0025. What are you supposed to do about that? Let's see. So 0025 is 2500 nanofarads, a huge number of picofarads. I don't have a capacitor like that in picofarads. So again, what's it doing? It's conveying the audio. The concern is the capacitance of this has gone away. Hey, why don't we measure this? Let's measure this. So I'm taking my time with this capacitor because I think it could be the cause of low audio. And I think there is low audio in the radio. Maybe not as bad as I thought. The alignment has picked it up a fair bit. 50 volts. The eye's popping right open like a bullet. Like a bullet. 150 volts. Like a bullet. Yeah, that's a bad sign. I'm looking for the rating, but they don't write it on these, so we're going to go higher. 250. It's popping open like a bullet. There's no sign that charge is going into the capacitor and then charging up. So the eye should be closing during the charging and then opening up. But what it's doing is just popping open. If I disconnect one wire and then run the test, get exactly the same effect. I think this is completely defective. How could the radio work at all? Okay, this is great. So 0.02, 0.03, I don't think it makes that much difference. Go bigger, go smaller. Go bigger, go smaller. Go bigger. We'll go bigger. Go bigger. Okay, so this is a 0.003. It's just a little bit bigger. Shorten up the insulation here. Now this wire comes off the volume control and has the potential to get caught on a grounded wire there right away. So they've insulated it, and it's even on the schematic showing that the wire's insulated at that point. shorter near the top. If you're going to make a choice on, if you're going to leave a capacitor in like this, with a long lead and a short lead, or you have your choice of where you want it up high or want it down low. What I was going to say, it doesn't actually add up with this capacitor. So you would want to put the longer lead towards the grounded end. This isn't grounded. This is floating in the circuit here. So I think what we're going to see when I do this is increased audio volume. Hey, I wonder if the fact that you can't zero the volume out will go away. I can't imagine how that would happen, but maybe it will. Oops. Okay. Is it long enough? It's not long enough. Oh, just long enough. Perfect. Okay. I'm going to solder the top one first here. Yeah, I cut those leads just a little too short. Watched a very interesting video yesterday on YouTube videos on the algorithm they use for, you know, putting out the advertising, all this kind of stuff, and what makes a YouTube video good from YouTube's point of view. It's quite interesting. No one knows for sure what they're doing on YouTube with their you know, when they're calculating deciding which videos to, you know, when you put a search term in, which videos you're going to see in the end. Turns out one of the qualities that YouTube likes is a video which the viewer, after watching, watches another video. In other words, stays on the platform. So it has little to do with the video itself, maybe. So YouTube would like my videos if what you do after watching this video is watch another one. And, oh, darn it, I had it and then I wrecked it. Because, you know, they're trying to put out advertisements. That's their business. You can't advertise to people who watch one video as much as you can advertise to people who watch many, many videos, right? Pretty simple stuff. I didn't know that. Okay, there we are. Hooked on. We're doing the hooky thing here. So this capacitor didn't measure leaky because it looks like it's open circuited. You kind of wonder how any audio could get through at all. Yeah, the chances of this vintage of capacitor not being leaky is really low. So if the leak test shows it to not be leaky, you got to be suspicious that there's something else going on with it. And now it's time for our daily reading of logical laws. Ready for this? A mother's law. Happiness is a warm puppy with an empty bladder. There we go. These are words of wisdom for today. I don't think it's going to help us here. We're ready again. So just switch it on and see what the meters say. That's what does the meter say? Okay, power on. First with the dim bulbs. Full power. Not touching anything. Oh, okay. Well, I hope you found that as exciting as I did. YouTube has volume limits on videos, right? So even the light's getting excited over here. Look at them. So that's made a huge difference. First of all, I can zero the volume out. And secondly, obviously there's a ton more volume available. So, I deem that totally successful replacement. Even my soldering iron's jumping up and down for joy there, singing its song. So, that's how we're going to proceed on the rest of these capacitors. But I think I've hit my limit for today. That was great. Yeah, that's great. Okay, so thanks so much for watching. And I hope the rest of the work I do on this radio goes along really interestingly. So I'll see you on that next video. Thanks again for watching. And thanks for the thoughtful, detailed, precise comments that people are leaving, that you may be leaving on my videos. Thank you for those. See ya.